Before learning about the circular queue, let's first understand why the circular queue was introduced. The array implementation has one drawback. There is a chance that some empty spots may remain at the front of the queue that cannot be filled if the back of the queue reaches the end. Thus, the idea of the circular queue was presented in order to get around these restrictions. The front of the queue is pointing somewhere instead than at the position 0. While the back is at last position, there are just two elements and three empty spaces in the array. The back is last point in the queue. If we try to insert the element, it will indicate that the queue is empty. One way to prevent this kind of memory waste is to move both components to the left and modify the front and back ends accordingly. It is not very practical technique because it will take a lot of time to change every piece. Using the circular queue data structure, it is an effective way to prevent the memory waste. Let's understand about circular queue. When it comes to the FIFO, that is first in first out principle, a circular queue and a linear queue are comparable. However, in a circular queue, the positions are connected from the last to the first. Here is the circular representation of the queue. The positions are connected from the last to the first, forming a circle. An alternative name for it is ring buffer. Operations that are performed on circular queue are NQ. It adds an element to the rear of the queue. DQ removes an element from the front of the queue. Is full checks whether the circular queue is full. Is empty checks whether the circular queue is empty. Display will display the elements of the circular queue. Now let us see the applications of circular queues. Circular queues are used in various applications where data is transferred in a circular manner. Here are some common applications of circular queue. The first one is operating system buffers. Circular queues are often used in operating system for task scheduling, managing interrupts, and in buffering. The second one is resource allocation. In systems where resources are limited and need to be allocated efficiently, circular queues can be used. For example, printers often use circular queues to manage the print jobs. Network traffic management. Circular queues are used in network traffic management systems to control the flow of data packets. Simulation systems. In simulation systems, circular queues can be used to model waiting lines, such as queues in banks, restaurants, and supermarkets. Circular queues are used in job scheduling algorithms to manage a queue of tasks or job waiting to be processed. Circular queues are used in data buffering applications where data is produced at one rate and consumed at another. In memory management systems, circular queues can be used to manage the memory blocks. Circular queues are used in handling keyboard input in computer systems. These are just a few examples, but circular queues are a fundamental data structure and find applications in many areas where data needs to be managed in a first in first out FIFO manner. Let us write an algorithm for NQ operation, that is insertion operation. Firstly, check if the circular queue is full. If rear plus 1% max size is equal to front, then the queue is full. If front is minus 1, it means the queue is empty. Then set front to 0. Increment rear by 1. But since it's a circular queue, use modulo max size to wrap around. Insert the element at the position indicated by the rear and return the updated circular queue. This is an algorithm for NQ operation. Now let's write an algorithm for DQ operation, that is deletion operation. Firstly, check if the circular queue is empty. If front is minus 1, then the queue is empty. Store the element to be deleted. If the front and rear are equal after deletion, it means the queue becomes empty after this deletion. Reset front and rear to minus 1. Increment front by 1. But since it's a circular queue, use modulo max size to wrap around. Now return the updated circular queue along with the deleted element. Now you know what is circular queue and why it was introduced. Also, we discussed the operations and applications of the circular queue and came across the algorithms for the NQ and DQ operations. In the next video, we will see the program for implementation of a circular queue using array in C language.